All right. So in the last part is they actually want you to do one of two things. They want you to tell me what numbers they would fall between. You should be able to do that without a calculator. What are all these bases going to be? Tens. So what we do is if this is 293,416, if you remember our base tens for whole numbers, we just count the zeros. How many zeros would this be? 5, right? So, but because it's larger than 100,000, it has to be between what two numbers then? It has to be between 5 and 6, all right? So that's basically what they want you to do first, is they want you to determine that this number would be between 5 and 6. I love that idea, but then if they're going to make you type it into the calculator anyways, you could just look at the number and go, it's obviously between 5 and 6. All right. To practice typing this in, if you do not know already, there's an on button in the bottom left-hand corner. You hit the on button. I would also then go ahead and clear a couple of times, make sure there's nothing going on in there. The log button is actually right below the second button, so you just hit log. Its natural base for this calculator is 10. I forgot who already just asked that, but there is a question, what happens if the base is not 10? We have an algorithm for that, so you could still utilize the calculator without being a base, whatever it might be. And I'll show you that when we get to it. And then it should say LOG with the parentheses. All you got to do is just type in the number, so 293,416, and then there you go. What it's going to ask you on the homework then is then just to round that answer to the nearest fourth decimal. Yeah. So fourth decimal, this then answer would be approximately 5.467 because the 8 tells the 4. Yes, that's going to be the first part's going to ask you what number is it between, and then the second part's going to ask you to round to 4 decimals. But again, I love the technique of just looking at it. You know, it's got to be greater than 100,000, but less than a million. But if they're going to make you type it in the calculator anyways, 5.4 is obviously between 5 and 6. So I think you can answer that question just as easily. All right, just sake practice, 897 will be between what two numbers without typing in the calculator? 2 and 3, right? It's got 2 zeros. Because remember, when we did it yesterday, we would ask you what's log of 100, right? And then we would count the zeros. That would be 2 zeros. So that means that this would be squared. But since 897 is larger than 100, but less than 1,000, it's got to be between 2 and 3. So between 2 and 3. And then what y'all get in y'all's calculator? Round it to 4 decimals for me. Perfect. Very good. What would this be between? It'd be -3, -4. Now remember, because if we do the decimal, I gotta make it a whole number. So I'd have to move it 1, 2, 3 times. So it'd be between. You would be right. Because it has to be less than -3. Yep. So it'd be -2 and -1 because -1's a larger number. And it's because it is greater than 1. So if it's greater than 1, it's got to be going into the positive section. So originally, if we would have just seen 0.001, we would have said, all right, that's 10th to the -3 power. But since 0.038 is larger than 0.001, then it's got to be between -2 and -1 because -2 is a larger number than -3. That makes sense? Does it? Do what? Oh, you did -1, -2. Remember, least to greatest. Oh, I got you. All right. But again, if that's confusing you, it's going to make you type it in the calculator anyways. What's the decimal? So then you can see that that is between -2 and -1. All right. They're going to make you do it anyways. It's a great technique, but you're going to have to type in the calculator. All right, so then this is 1, 2, 3, 4, 5. So therefore, what's it between? -4 and -3. Because it would be at -5 if it was 0.0001, but then this is larger than that, so it's got to be between -4 and -3. And what's that give me? Perfect. Now, this is times 10 to the 8th power, so that just tells me I would move this decimal 8 times. So how many zeros then would there be? 8. All right, so it's got to be between what two numbers? 8 and 9. Because it's going to be, well, I don't know what 8 is. What's that? 3, 6, 100 million? So it's got to be between 100 million and 1 billion. So that'd be 8 and 9, which approximately is what? It's a 9. So what would be the decimal? Perfect. You do have to add the 0 to show the reader that you have rounded to the 4th decimal place. All right. I know it might not, this is the same thing as 0.959, but not the equivalency. So you have to put the 0. All right. That's a science term for you as well. All right. So this is -2. So what's it going to be between? Good. -2 and -1. All right, gives you that right there. And again, this would be bigger than 1, so it's got to be bigger than -3. All right, which is approximately. Questions on that? All right, let's practice with the natural log. So on number 14, if I give you, okay, after this period. After this period. That's right. You're welcome. All right. Me too, man. It's like my asthma is flaring up. Like, all right. So if f of x equals the natural log of x, I want you to find these guys. F of 1,860. F of, that's an ln for natural log. I want you to find f of 0.0694. I want you to find f of the square root of 87. I want you to find f of 2 pi. I want you to find f of 1.3 times 10 to the 12th power. And I want you to find f of 8.5 times 10 to the -17th power. Round to 4 decimals. All right, if you don't know how to do that, just like before, you want to turn your calculator on in the bottom left-hand corner, hit clear a few times to clear everything. If you look right below the log button, there's an LN button known as the natural log. Again, it'll have LN with the parentheses. Just type in these guys. So if f of x is equal to the natural log of x, then if I want f of 1860, I plug 1860 in for natural log. So I'm just going to type in 1860, hit enter, and I get a decimal. So you see the log button that we hit earlier? Right below it is the natural log button. And so this would just be 7.5283. Nope, not on this one. Not with natural log. You remember natural log has a base of what? If I had to rewrite this in log terms, its base would be what? E. Very good. And we don't have normal numbers for E. All right, do we have an answer for B yet? Perfect. Do we understand how to put the square root of 87 in there? So let's see. So it'd be natural log or second x squared. So the square root will appear. 87, close parentheses, hit enter, and I got 2.23. So hit natural log. So you hit natural, oh, good. And then second x squared to make the square root appear. 87, close parentheses. There you go.
Yeah, I only put one.
Oh, gotcha. I just, if you had to write it twice, you're closing the square root and then you're closing the log. Yeah. I guess it accepts the one. Yeah, as long as it accepts it, that is all that matters. All right, so what was that answer? All right, and if you look at pi, is there a pi button? Oh, yep, a legit pi. I'm looking for it in blue. So what y'all get? Good. Everyone find the pi button? It's right below LN. Yeah, I was looking for it in blue as well. All right. So this is just like what we did with log, just with LN. Yes. Yes. 5 or up, go up. 4 or less, stay down. Or stay the same. Yeah, make it 0, add 1 to the next placeholder. All right, what about E? What did we get? Perfect. What did we get for F? Okay, so you didn't get that for E? Okay.
My brain was not active when you were explaining.
Okay, so we'll hit LN for natural log, and then it's 1.3 times. And then I think they actually have a 10 button. So second. Oh, no.
Oh, second. That's what I did. Okay, I see. Second.
And then, yeah, then you would plug in 12. It was 12.
LN.
Times. Second long. There you go. And then 12. There you go. Right. Any other questions on how to do this in the calculator? All right, there you go. So let's move on to objective 3. So objective 3, we're going to apply basic properties of logarithms. So here's a lot of notes that we're about to have to write. So let me go to that part. Here's all your properties that you need to know. Logarithmic properties. Logarithms, yes. The first one you need to know is if you have log base b of 1, it will equal 0. Right? The reason, because base b of 0 is going to equal what? 1. It doesn't matter what the base is. If you have a 1 there, it's got to be 0. Right? So you should see, anytime you see a 1 here, instantly 0. Okay? Like base 1 of 1 equals, it'll still be 0. As long as this guy right here is a 1, it doesn't matter what this is. All right? The second property, if you have log base b of b, the answer is going to be 1. And it makes sense because I would write the base b raised to the first power. And what does that give me? B. So if the base and the number I'm taking of is the same, instantly 1. Okay. Third property, if you have log base b of b raised to the x, the answer is x. Now here's the reason why. If I take my base b, raise it to my y value, that will equal what's inside. All right. So if I am taking a log of a base with the same number raised to anything, it's going to be that value. Does that make sense? Okay. The last one, if I have b raised to the log of base b of x, the answer is x. Subscript b, normal x. Normal b raised to the log, subscript b, x is on the same line as log. It's not floating. Well, I'm telling you, if you had good handwriting over here, this would be a good one. All right, to write this out in logarithmic form, this would be log. My base was b of my x value would equal what it's being raised to, which is that. So this happens because of this. So anytime that you have a number raised to a log with the same base, it's just going to be this guy. Basically, those will cancel. You're left with that. I'm going to start taking points off. So I'm going to do. You want to be so critical? When you turn in your test, if it looks like it's floating, the entire thing is wrong. Perfect. Okay. They should all be perfect. All right, let's do an no, sorry, an example. Are we on 15? Number 15? I don't know what number we're on. I want you to simplify these expressions. Log base 6 of 6 to the 7th power equals what? Log base 6 of 6 raised to the 7th power equals what? Nope. What is x? 7. So if the base and the number of is the same, the answer is the exponent, which in the case, the x is the 7. So we good there? These are the properties that we're going to use to simplify them with. Number 16, log base d of d equals what? Nope. 1. If these guys are the same, think of it like this. This has the same property here. What's d raised to? If it doesn't have a number, what's it raised to? A 1. So this kind of uses the same property. D's cancel, the exponent becomes the answer. Okay. It's b raised to the 1 to give you d. Sorry, d raised to the 1 to give you d, not b. D, b's. This will hurt a dyslexic kid right here. All right. Number 17. 4 raised to the log base 4 of a minus c. What's that equal? A minus c. No, it's a 3. It's a 3. But it's curved that way. If you said I would say, okay, you didn't see the, okay, that makes sense. But that's a C. C. C for correct. Basically, as long as the number here and the base here is the same, whatever I was taking the log of is the answer. All right. One more, and then we'll move on. Natural log, so number 18, sorry, number 18. Natural log of e raised to the x squared plus 1 equals what? X squared plus 1. What is the base of this natural log? Is the base and the number of the same? So therefore, it's just the exponent. I didn't. I just wrote it. You got to know that the natural log has a base of e. Just like if I just wrote log, it's a base 10. So we good there? Make sense? Easy peasies? All right. Easy. Yes, you need to know those 4 properties. Objective 4. Graph logarithmic functions. Enough to put a graph. So here we go. We got y equals log base 5 of x. So only thing you got to really pay attention to, this is number 19. Here is the generic form, y equals log base b of x, all right? Where b, if it is greater than 1, joy to the world. That's what it's going to look like. If b is between 1 and 0, for some reason, this is really, oh, okay, so I'm going sideways. Okay, that makes sense. Goes like this. It's never going to cross the y-axis. This is a logarithm, not an exponential. So an exponential, it never crosses the x-axis. Logarithm never crosses the y-axis. As long as it's a, I think it's as long as the x is positive. If the x is negative, it will flip across or reflect across the y-axis. And this doesn't plateau either, just keeps going. I don't know how to write that. It just doesn't cross the y-axis. So I'll go a little bit further in detail. So if we take our f of x equal to a log base b of x minus h plus k, just like all of our other transformations, this would shift up or sorry, left or right. So if it was negative, it would go right. Nineteens for this problem. I haven't finished it, but I'm writing notes. That's an H. This, it's an arrow. You are so judgmental today. That's interesting. Wait, what? Say it one more time. It's being multiplied to the log. Yes. Mm. All right. If A is less than 0, that's what you were asking earlier, it actually is going to reflect across the x-axis. If this x is less than 0, meaning it has a negative in front of it, then it will reflect. That's not how you spell reflect. I don't even know what I'm spelling here. No, it's just 1K. Not okay, okay. Okay, so reflects across the y-axis if the x is negative. So if I'm just looking at this, this is also, add some more notes here. This is like your x-intercepts. So the A is where I'm going to cross. So this would be like at 1. All right, so if I had a graph number 19, let's put it all together now. I'm just trying to give you all the information you need. Look, we should have done a lot of things, all right? All right, so since my A is what? Positive. Well, it's positive, but it's 1. So I'm going to cross at 1. Are we? The B is greater than 1. So therefore, it's going to be like almost like an exponential growth. Yes. There you go. Yeah. Oh, no. No, can it? That's a good question. Can B be greater? If B is 1, then that would be the base. Oh, no, it can't. If the B is 1 as a logarithm, it'll just be a constant number. Because if you think about it, if you change a logarithm into an exponential, if the base is 1, that would be your base for your exponential function. So it'd be 1 to some power will always be what? Well, it'll be a line. Yeah, it'll just be 1 all across the board. So that's why B can't be 1. Because if it is, it's no longer a logarithm. It's just a constant function. That's a good question. That made me think. That was good. All right. So let's do another one. Oh, come on. I feel the cancer hitting me. All right, number 20.